These are only one-sided. Wait, go back. That's confusing. Yeah, it's one of those. That's one of these things. I gotta look at no, yes, it is. They attached these to it. Oh, I'm getting so confused. No, you have to first. Wait, no.
Oh, wait. Is that?
Keep in mind you've got like 20-some images to work with. If you're not getting the information you need out of one picture, try a different picture, right? Yes, sir. One of the things that you definitely can leverage when you're looking at the design of the robot is symmetry. Why would I say that symmetry is something that you can leverage to figure out how to build your robot?
Because one part is going to be the same as the other one.
Exactly. Right. And there is a significant amount of symmetry in this robot. Remember that when you're looking at these different pieces, there are several L-shaped technic pieces in the design. There's a larger L and a smaller L. Keep that in mind when you're looking at it.
Yeah, I can't.
They also have, the smaller L has some cross holes, and the larger L has all round holes. Do you guys remember what sensor that is?
Light sensor.
Yeah.
It is? The light sensor? Right, and it measures what?
Reflection, right?
It does. The amount of reflection. And how do you think you're using that in sumo?
Oh, you already got it?
Yes, next one.
Now I don't get it.
And black tape, and we need to make sure it doesn't get on the black.
Correct?
That's right. Yash, what were you going to say?
I was going to
Coach
say
Scott,
That's right.
Coach Scott, I don't get how these.
Wow, looking good, guys.
This probably is better.
Looking good. I can see sumo bots almost ready for the ring, right? Cool.
I've got a good hunk of it done. Yeah, we've got that part done. We've got the base done. Let's go to the ring.
Good. I think it's interesting to see how different teams start from different points when they're building their sumo bot.
I always go for the guard barrier that can attach the wheels.
Right. I've seen some teams kind of start top down. They start with the brick and they build everything coming down from the brick. I've seen other teams build the base
What can we do here?
with the motors and then put the brick in at the end. Remember, don't pay attention to the color of the beams in the pictures. It might be the same color, it might not. Remember to count the number of holes, so the number of units for each piece, right? Cool, and then once you've got one wheel, you've got both of them. Cool.
Whoa.
And then once you've got both motors built, then you can use the brick to attach the two together.
My motor's
Okay,
crooked.
so,
I'm not sure if you built it wrong.
so basically,
Okay,
I'm
so
going to
first we have to figure out what connects
Is
to
that
that
the back
to
or is
that.
that the front? Oh, we're supposed to have two of those.
See?
Okay, so basically it's just symmetry at this point.
Simple as that.
Wait, what? 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 There we go. What? Okay, it connects to the brick.
Coach Goff, I think I'm missing like two pieces.
Looks like two.
Yeah, we have
No.
these that are yellow.
I know how many go there.
Okay.
There.
15
one in there. One and
We're missing like
One right
two
there.
pieces that
There's
are
one there. And
Where?
it looks like there's one right there. There's gonna be one there, and one. There's three holes right there.
In the middle one.
Is there one in there?
Nines. So,
Yes.
So hang it in there.
That's all I
These are
needed
nines.
to know. How
Right,
hard
so
is it
two
to
in the
answer?
back,
I don't
three,
know.
6, they're longer.
I don't know.
Those are
Depends on the
longer.
question.
So, yeah.
I don't know.
So just get it in.
Three go in. Like if I
So the back
ask,
part of
three
the
go in, right?
sides
If I ask,
should be,
three go in,
the top is
correct?
11 long and then the ones in front are 9s.
The ones in front are 9.
Yeah. So these,
I'm not
top,
sure. Does that look
9,
right?
3,
I think it's actually.
yep, and the other ones at the back are 11s.
No. Where? There's one in there. We'll find out eventually. Let's find out.
Now, one of the things that you're going to have to kind of
Hey,
deduce.
go back.
Hey guys, real quick, I need your attention. If I am asking you to use deductive reasoning, what does that mean? Anybody know?
Process of elimination.
Exactly.
Yes.
Good. And what else?
So basically just, if something doesn't work and if you know it's not this, mark it off, it's not that. Move on to something else and then it's not that, mark it off and go something else.
Good. Right, so deduction is kind of like, just like what Yash was explaining. You can take what you know, and if you try something that doesn't work like Yash was taught, you can eliminate that possibility. So one of the things to note is that the rubber part of the wheels cannot touch the robot or you're going to have friction. And if you have friction, your robot is not going to go straight, and it's also going to not have as much pushing power, which for sumo, we definitely want the pushing power, right? And there's a particular piece in your set that you probably can use to space them.
Maybe it's called a bush. Maybe it's called a bushing. I cannot get out of it. Maybe it's something I can get out of it.
We're going to use the sound sensor for our sumo bots. Why do you guys think we're going to be using the sound sensor for our sumo bots?
I don't know. Where would it go? I don't know where it goes.
It's a sensor right in front of us. I've done this before.
A sound sensor? Not those sound.
Where does it go?
It goes in the back. I'll show you.
Oh, yeah, because so you start on the same time.
Exactly, right.